And for number 19, we have our last big lecture of this unit. We had some little itty bitty stuff, community level stuff, basics of ecology stuff. Little carbon is pretty easy. Big carbon is a bit heavier and kind of a big deal. And now comes the nitrogen cycle, which I think most students would argue is the most like, what the heck is this guy babbling about, part of unit number 2. Now, like I said, we're almost done with unit number 2. After this lecture, it gets pretty mellow again all the way to the end. So there is light at the end of the tunnel, but you're about to make a really big drawing with a whole bunch of notes. Now, you are going to have to draw with me. I'll be doing that. So before we get into that, there's like a couple of things that I probably want you to know, and you may want to write these down at least in abbreviated form. First, remember that most nitrogen is in the atmosphere, and it only ends up in the biosphere briefly. There is some nitrogen locked up in rocks, usually organic compounds that get trapped in sediment, like we talked about with carbon. There is some nitrogen dissolved in water, nitrate. But almost all of our planet's nitrogen is in the atmosphere. It's about 72% of the atmosphere. It's a whole lot. Like by volume, if you look at the atmosphere, almost all of that is nitrogen. And life uses nitrogen in a variety of compounds, but basically the biggest reservoir is up in the atmosphere. And as life is using nitrogen, it kind of escapes back to the atmosphere. Okay. Number 2, it's important to note that basically all the chemistry we'll be talking about and all the reactions we'll be talking about are done by bacteria. I don't think I understand why that is, but essentially all the nitrogen cycle stuff is either this type of bacteria or that type of bacteria. And instead of thinking of this as a cycle, it's probably more accurate to think it's like an ecosystem. There's all these different bacteria that just, they have their lives, and like one of them takes nitrogen in this form and craps it out in that form, and then there's like some different bacterium out there that's like, oh well, that looks pretty useful, and then they do their transformations with it. Bunch of different bacteria that each do other reactions, different reactions, with nitrogen. Okay. Fourth, it's probably important to point out that like lightning and volcanoes just do weird chemistry stuff. There's like a lot of energy, so they do weird chemistry. That's pretty much true in all chemistry. All right, don't be intimidated, but please just bear with me for a minute. I'll give you a better picture for you to draw later, okay? So just give me a second here. I want everybody to notice that I've got this shape that's kind of like a lowercase n, right? Maybe you can see this. If I was to write, if I was to write a lowercase n, and then I traced around that, that's the shape of the nitrogen cycle. And then we're gonna like slice that right through the middle with above ground and below ground. So I'm gonna clean up this drawing. You don't have to draw anything yet, okay? But we're gonna start with gas. We're gonna go underground, then we're gonna come above ground, then we're gonna go underground, and then we're gonna go back to gas, okay? That's the pattern that we're gonna flow through. And I'm using this drawing because it's got like everything underlined, but it's kind of tough to read. So I will talk you through what it says in each part of this. but you may want to take a minute and like get the basics of that drawing. So I'm going to clear up all my mess, and then I'm going to give you a slightly better image. Okay. And I think I should probably ask you to pause so that you can draw as much as you can. Okay. So please take a minute, pause now, make the drawing. And I'll assume by now that you've drawn what you could. If there's words you didn't get, that's fine. Just draw what you can. Okay. So if you take one big breath and you go, your lungs at that moment are 72% nitrogen gas. And you should know that nitrogen's one of the big six. You don't get life without nitrogen. But here's a funny thing. When you go, that's also 72% nitrogen gas. So you can breathe it in and you can breathe it out and you need it for life, but you don't get it that way. We could start with this up here. That says nitrogen gas. That says 72% of the atmosphere. You should know that we always write the gas as N2. We can talk about this later, but it's a diatomic gas. So this element likes to be in a buddy system, N2, diatomic, two atoms together. Okay, nitrogen gas. And some people describe that compound as molecular or atmospheric or gas. Okay, common in the atmosphere. Life doesn't usually use that. Okay, there is one organism that can breathe and absorb and use nitrogen gas. It's this bacteria that lives in the ground. It also lives in the roots of some plants, and it's called nitrogen fixing bacteria. I'm going to need you to write some stuff down, okay? So these are, I'll say all that again, nitrogen fixing bacteria, nitrogen fixing. They live in the soil and they live in the roots of some plants. And they've got this really neat trick. They live interesting bacteria lives. They have reality television and gossip and Instagram stars and stuff. Their life is rich and interesting, but one thing that they do, these nitrogen fixing bacteria, is they breathe in nitrogen gas and they exhale this stuff that says NH4. That's ammonium. That process is called nitrogen fixation, and it means to make nitrogen useful to life. You see, ammonium, that is useful. So make sure that you pause so that you can write all this down. But nitrogen fixation is a process done by bacteria. They're called nitrogen fixing bacteria. And they turn nitrogen gas into ammonium. By the way, do you all realize that if you're a bacteria, soil is full of little air pockets, right? Like, you know that farmers till the soil to make it fluffier so there's more gases getting into the soil. So when you and I look at dirt, we would suffocate, so we think of it as being without gases. But there's quite a bit of air in the soil. That's what these guys are breathing. They all live kind of in the top, like, few inches of soil. So that's where all of the gas exchange happens, okay? So nitrogen gas, only useful if you're nitrogen-fixing bacteria, because there's this process called nitrogen fixation, where some metabolic thing inside of these bacteria inhales that nitrogen gas and dumps into the soil ammonium. Okay, I'm going to clean up all my sloppy drawing. And now we're going to go to the next part of this ecosystem. That ammonium that was left behind by the bacteria, this stuff, that's really useful to life. That's the number one fertilizer. Sorry, that's supposed to say fertilizer. It's the number one fertilizer is ammonium. It's the most important ingredient for plants to grow. It's the number one thing. All plants need it, ammonium. And plants can't breathe nitrogen gas, but they can drink ammonium out of soil. That process is called assimilation, where they take the ammonium and start to use it in their tissues. They take it out of the environment. It's uptake, right? A type of uptake where they put something into life from their environment. And it's called fixed nitrogen. Again, this is just vocab because that's nitrogen in a form that's usable to life. We call that fixed, right? Fixation makes it fixed. Fixation makes it from useless to useful. You might know this from that study goal about the big six, but nitrogen is used to build proteins. So inside of the plant, all of the ammonium that it has taken out of the environment is used to build proteins, more specifically amino acids, which are the building blocks of proteins. You assemble amino acids to get a protein. Okay, so in this plant, nitrogen now lives as amino acids. Amino acids are part of protein. Make sure that you have that written down somewhere. So we had ammonium, NH4, in the soil, and after assimilation, that's used to make amino acids. Metabolic process of the plant, it grows. This is one of the things that plants do at night. When you thought that plants were sleeping, plants are working really hard to build their proteins. Okay? Again, I'm going to clear up all my slop. And keep in mind that proteins are really important for consumers, right? So I've drawn in a horrific, deformed, embarrassing rabbit, and my horrible rabbit is eating that plant. This says digestion, where inside of the rabbit, the proteins are being digested. The proteins of the plant are broken up into amino acids. The rabbit will reassemble those into rabbit proteins. And then there's probably going to be some leftover ingredients that says poop. So nitrogen went from gas to ammonium in a process called fixation. And that ammonium was assimilated to build amino acids in the plant. The plant was eaten by the rabbit, who digested the proteins in its diet, got rid of the amino acids it didn't need. We call that poop. There's other stuff in poop, but this is where the nitrogen is going, from gas to ammonium to amino acids to the discarded amino acids here. Okay, I'm going to clear all this up. And there are decomposer bacteria that will turn that back into ammonium. I know this is just a bunch of babble by now, right? At some point you're like, Jose, why are you talking about all this? I kind of wonder that too, but I guess I'm talking about this because the College Board always asks. Bear with me. We'll go through a few times and then it starts to look a little cleaner. Just bear with me for a moment. decomposer bacteria will take the stuff that's in the poop and make it back into ammonium. That process is called ammonification, where amino acids are made into ammonium. And you have to know that because the College Board is guaranteed to ask you this. I don't know why they're so obsessed with this, but they always ask. Now, this is also why poop makes good fertilizer. Maybe you know that like manure is a really good additive for soil. Manure is a good additive for soil because decomposer bacteria will turn that poop into ammonium. And remember, ammonium is the #1 nutrient needed for plant growth, right? So plants actually get ammonium from 2 sources, from bacteria that live in the soil and from crap on the surface. Okay, so ammonium flows this way, but technically, look, ammonium can also flow that way. See, that says nitrogen shortcut, right? Because poop decomposes to ammonium, and that ammonium is useful to plant life. I fully realize that you might want to watch this video multiple times. Just saying, that might be smart. Okay, now there's just 2 more bacteria that we need to talk about and we're done. Unfortunately, you got to know them because the College Board is obsessed with asking about this one slide. So I would be remiss not to help you with this because it's so easy to just memorize a couple of words here. Ammonium is used by some type of bacteria to make nitrate, and nitrate is used by another type of bacteria to make nitrogen gas. Remember, I told you there's just all these different bacteria that live interesting bacteria lives. And in the course of being bacteria with interesting bacterial lives, they like do some stuff with nitrogen. They're called nitrifying and denitrifying bacteria. Nitrifying do nitrification, which is to make ammonium into nitrate. And then denitrification is making that nitrate back into gas. And I don't think you'll ever need to know this again. If you want to have a saltwater coral reef aquarium someday, you'll have to know this. And if you want to have like pretty fancy like freshwater aquariums with like living plants and stuff, you'll need to know this. And if you're going to take the AP test, you'll need to know this. And if you're not going to have coral reef aquariums or living plant aquariums, or if you're not going to take the AP test, you'll probably never need these words again in your life. But here's me trying to be helpful. Now I'd like to go through this. Just a quick second lap, but this time I'm going to color code it, okay? So first, I want to follow all the different types of nitrogen, okay? There's nitrogen gas. I wonder if I could make these colors better. Let me see. Don't you feel like that's not dark enough, right? Like that, doesn't that look like it's too faint? What if I do this? Let's see. Oh yeah, that's better, but that's not big enough. One more try. All right. Oh no, what have I done? Whoa, I think I have lost. Oh, there it is. Okay. Sorry, kids. I warned you. I'm tired. All right, here we go. All the different types of nitrogen. There's nitrogen gas. There's ammonium. There's amino acids. Again, ammonium. Nitrate. and gas again. That's really only a couple of different chemicals to know. So in terms of total chemicals, you can do this. Now there's some vocab, right? There's nitrogen fixation over here, assimilation over there. There's ammonification here, nitrification, and denitrification. So like 1, 2, 3, 4, 5 vocab terms. This is why they love this on every single AP exam. It's like a multiple choice question that's pre-written in the curriculum. It's like, oh, here's 5 words you got to know. And they're like A, B, C, D, E. There's something else I'd like to highlight, if you don't mind. Nitrogen fixation is done by bacteria. Remember, they live in the soil or in the roots of plants. Those little places where they live, that's called a root nodule. I don't know if you need that for the AP test. Maybe you don't. Digestion is done by bacteria. Ammonification, that's a decomposing bacteria. Nitrification, that's bacteria, and you can see that they add oxygen, so we call that an aerobic bacteria because they're using air, right? They add oxygen because they've got plenty of oxygen because they're aerobic. And then this one is stripping away oxygen, so they must not have any oxygen. That is anaerobic bacteria. But again, that's also bacteria. So we've got bacteria in the soil, we've got bacteria in the gut, we've got decomposing bacteria, nitrifying bacteria, and denitrifying bacteria. That's a whole bunch of bacteria. That's why I said you kind of, if you just think of this as an ecosystem of different bacteria, you've got it all. There's really not a lot else. Okay, so vocabs, nitrogen fixation, assimilation, ammonification, nitrification, and denitrification, that's vocab. Chemicals, nitrogen gas, ammonium, amino acids, ammonium nitrate gas. We can do that. A few different types of bacteria. And hooray, that is the entire nitrogen cycle. You may want to watch that video again. It's just a bunch of babble that you have to know for the AP test. This is one of the less valuable things we do in my class, but I got to get it out of the way before we move on to bigger and better things soon. We are almost done with this unit. If you've gotten this far, you've gotten through one of like the horrible, ugly battles of apes. I'm proud of you for watching so far. You're doing great. This is a good benchmark. Like you got to a good point here. I'm going to stop and I'm going to get some sleep.